Solve quadratic equations in the complex number system. Remember that the complex number system simply means we're dealing with imaginary numbers. So first things first, let's solve 2x squared plus 32 equals 0. Now when you're solving quadratic equations, it's always good to take a look at what you have. So notice that the only variable term that we have is x squared. Therefore, we can solve using the square root method. Get that x squared by itself. So we're going to subtract 32 from both sides and then divide by 2 to isolate that variable term. So when I subtract 32 to both sides, I get 2x squared equals negative 32. Then I divide both sides by 2, and I end up with x squared equals negative 16. Now that I have isolated the x squared, I can solve for x by taking the square root of both sides. Now, when you have the square root of a negative, that's where we get our I. Now, don't forget also, when you are solving a quadratic using the square root method, when you take the square root, we have our plus or minus. Because remember, like 4 times 4 is 16, and negative 4 times negative 4 is 16. So we need that plus or minus. So we have x equals plus or minus the square root of negative 16. If I have a negative under the radical, that's where my imaginary number comes from. So I'm going to end up with x equals plus or minus 4i, because the square root of 16 is 4, and a negative under the radical comes out as our imaginary value I. Let's do another one. Let's solve 2x squared minus 8x plus 11 equals 0. Well, now we have an x squared and an x term, so we can't necessarily use the square root property. And we can try all we want, but solving this by factoring doesn't work either. So we're going to have to go ahead and solve this using the quadratic formula. So first things first, let's identify our coefficients. So we know that a equals 2, b equals negative 8, and c equals 11. Recall the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Let's substitute in our values. So I end up with x equals the opposite. When I say the opposite, that simply means the negative, right? So negative of b, which is negative of a negative 8, plus or minus b squared, again, b is negative 8, minus 4 times 2 times 11, all over 2 times 2. Now it's time to simplify. When I do that, the opposite of negative 8 gives me a positive 8, and then underneath the radical, negative 8 squared is 64, and negative 4 times 2 times 11 gives me negative 88. So it simplifies to be 8 plus or minus the square root of 64 minus 88 all over 4. Let's continue the simplification process. I'm going to work underneath the radical. 64 minus 88 gives me a negative 24. Now let's simplify that radical to try to make our life a little easier. So a radical, the square root of negative 24 is simplified. The square root of negative 4 times the square root of 6. Well, the square root of negative 4 is 2i. So I end up with 2i radical 6 as a simplified version. So let's go ahead and substitute that in. So instead of a square root of negative 24, I have 2i radical 6. So I now have x equals 8 plus or minus 2i radical 6 all over 4, which is essentially our answer, but let's work on simplifying that further. We can we can split this into two terms in order to simplify, meaning in the numerator we have 8 plus or minus 2i radical 6. All of that is over 4. So I can change that to be 8 over 4 plus or minus 2i radical 6 over 4. You'll notice that each term can be simplified. 8 over 4 reduces to 2, and in the second term, I have 2i on the outside of the radical and a 4 on the bottom. Well, 2 and 4 are both reducible by 2. So 8 over 4 is 2, 2i over 4 is i over 2, so I can simplify this to be 2 plus or minus i radical 6 over 2. If I want to give that as two separate answers or solutions, I have 2 plus I radical 6 over 2 and 2 minus I radical 6 over 2. Because remember that plus or minus is what gives us our two separate solutions.